GMGM. Welcome to what's going to be a special edition episode of DevNTell, powered by our friends at Arbitrum DAO. So, in the month of July, we're going to be test running a new series called the Builder Series. And in this series, we'll be hosting some really fantastic builders in the Arbitrum ecosystem who will be showcasing their products to us, as well as some tutorial content developed by myself to help you upskill your game in the Arbitrum ecosystem. And today, what we'll be going over is bridging. And what you'll learn from today's video is how to create an ERC20 contract that will be deploying on the Ethereum Sepolia network. And then we'll be using Arbitrum's seamless bridge UI to magically create a equivalent token on their network on the Arbitrum Sepolia side. And we'll also be going over how that's actually working under the hood. All right, let's get into it. All right, let's kick things off with doing a forge init of our project. We'll call dev token demo. Run that. Nice. So let's now go into that folder, dev token demo. Nice. And let's launch Visual Studio Code. So first thing I want to do is I'm going to open up a new terminal, and I'm going to do a forge install of the Open Zeppelin contracts so we can use them to create our token. So just let that install. Nice. Now I'm going to copy over some Foundry Toml configuration settings just for some styling stuff and setting the Etherscan environment variable that we'll use for verification of our contract. Nice. So now I'm going to also create a remappings file. This will just help us be able to import our Open Zeppelin contracts in a nicer way in our Solidity contracts. With that done, now let's just go and clean up all the pre-built contracts that came with the forge in it. So get rid of the counter.sol, the counter.sol script, yep, trash, and the test here. There we go. So let's start with creating our dev token. So what I'm going to do is I'm going to create a new file. I'll call it dev token.sol. And we're going to start with some regular housekeeping things. So I'm going to define the license, spddx license, not MIT, we will go Apache. And for Solidity version, we will go 8.24. And what I'm going to do is I'm going to import the library that we installed from Open Zeppelin, the ERC20 burnable extension of the base ERC20 implementation, which will just basically allow our token to be burnt. And now we can define our contract. Dev token is ERC20 burnable. Sorry. And we can get rid of this AI generated code. We will close our contract definition there. And what we're going to do now is we're going to define some state variables. So we are going to define the name of our token, which will be dev token, the symbol for our token, which will be dev in all caps, as well as a max supply, which we are going to set at 1 billion tokens. So this is the cap of the number of dev tokens that can ever be minted against this contract. And I'm going to set the decimal places of this token to be 6 decimal places instead of the default 18. And all you have to do basically to achieve that is override a particular function, and I'll show you how to do that in a bit. Next, I want to define some error events that we will emit when particular error cases show up in our code. And I will also create a modifier that will basically be a helper function that will check methods that take in an amount and ensure they are a non-zero amount. And if not, they are we will emit a dev token amount must be greater than zero error. Now for our functions. So first thing we'll want to define, of course, is our constructor. So our constructor will take in an initial supply. So this is how much initial dev token will be minted. It'll take in our name and symbol, which we've defined above here. And we will also check that the initial supply that's passed into the constructor is a non-zero value. We will also check whether or not the initial supply that we pass in is a number bigger than the max supply, and if it is, we will revert accordingly. And finally, we will mint. We will mint the initial supply of tokens and pass them along to the creator of this contract. Next, we will ensure that our token is indeed set to 6 decimal places. And how we do that is we very simply just override the decimals function and return 6. And that's basically it. Next, we will define our mint function. The mint function will mint the tokens to a given address based on the amount that's passed in. And again, we're going to do a more than zero check here because we don't want to do the work and pay the gas to mint a zero amount of tokens because that just doesn't make sense. So what we're going to do is do some checks and balances to make sure that the amount that we're minting doesn't put us over the total supply, or the max supply rather. And if it is, we will revert with an error. And then on the happy path, we will mint the token amount and pass them along to the address that was specified. And finally, we will burn, or we will define our burn function. So this will allow holders of our token to be able to burn said amount of token if they so choose. And again, we want to ensure that the amount that's being burnt is a non-zero amount, and checking whether or not the balance of the caller is, or basically whether or not they have that amount of token they're trying to burn. And if not, we will revert with not enough balance error. And finally, we will call the burn method of the parent function, or of the parent contract. Now I'm going to create a devtoken.s.sol file, which will be our deployment script. And it's a very, very simple deployment script. I'll just copy it here. Come on now. Paste it in. And basically what we're doing is we're just starting a broadcast. We're minting an initial supply of 1 million tokens and basically returning an address. All right, so now let's actually deploy the thing. All right, so now let's deploy our dev token to Ethereum Sepolia. So, but first, some housekeeping. Let's do some formatting. Then let's do a build. No, actually, let's do a clean. And now let's do a build here. Compiling. Nice. We have compiled. Now I will paste over the command to run our script. So basically, we're going to run our dev token deploy script against the Sepolia public RPC using our private key and our Etherscan API key and doing verification. So when we're doing verification, what that'll do is basically verify our contract using Etherscan, which will allow us to actually see the code on their site. And looks like it's running through its motions, so we'll just wait till it finishes. Nice, finished. Before we actually go into showing you how bridging works, let's take a step back and explain what bridging is. So, to understand, I think a good first place to kind of touch on is blockchains themselves. Blockchains, they're walled gardens, if you didn't know, and they don't have native support for talking to one another. And because of that, what some people had to do is create some constructs to be able to transmit information from one chain to another. And one of those constructs is called bridging. And what bridging allows you to do is move tokens from an origin protocol to a destination one. And usually, what this is made up of is three components. One is the actual smart contract representing the token on the origin chain, an equivalent smart contract on the destination chain, also representing the token, and something called a bridge token that sits in between, that acts kind of like the accountant, making sure all the checks and balances are in place when you move tokens from one end to another, and also helps with minting tokens on the destination chain. And usually, what happens when you move funds from one chain to the other is those tokens from the origin chain become locked on this bridge contract, and an equivalent amount is minted on the destination and placed in a equivalent wallet address as the one they originated from on the origin chain. And once they're bridged, you're actually free to be able to move them back and forth as you please. You can also move these tokens on the destination chain to another address. But of course, if you do this, you are no longer the owner of those tokens, and whoever the recipient is can move them back and forth. And if you've ever tried to develop a multi-chain application that required a bridge tokens, you probably went through some pain trying to actually perform the bridging. However, the folks at Arbitrum have actually made it really easy to be able to bridge a token from Ethereum to their chain using a bridging UI that kind of feels like magic, to be honest. All you really need to do is paste an address, pay some gas, and the bridge will automatically create you a smart contract on the Arbitrum side and take care of all the nuances that are involved. Well, I mean, that's enough talking from my end. Let's actually show you how this works. All right, let's bridge our token to Arbitrum Sepolia. So I'm going to head over to bridge.arbitrum.io. I'm already logged in here. I'm going to paste in the contract address of the dev token. I will select it, and I have some funds in there already, so I'm going to move 90. Now what I have to do, click the Move Funds to Arbitrum Sepolia button. I understand. Pay some gas, and I will have to sign a transaction here, approving that. And what this has effectively done is it's kicked off a process utilizing the bridge contract on Arbitrum to move. I got to sign one more thing here. As I was saying, this has kicked off a process, as you can see here, that is going to move our dev token from Ethereum Sepolia to Arbitrum Sepolia completely permissionlessly, I should mention. I didn't have to go through any approval processes or anything. I simply just copied and pasted my already deployed token address, and this bridge developed by the folks at Arbitrum is basically automatically creating a clone contract of our dev token implemented as a standard ARB ERC20 implementation, which is just another flavor or extension of the ERC20 implementation created by the folks at Offchain Labs. And it is coded as, or it will end up on the Arbitrum Sepolia end as a proxy contract. So what we have to do is essentially wait a grace period of around 10 minutes for this process to complete. And after that, our token will be magically on or magically bridged to Arbitrum Sepolia. All right, let's take a bit of a break. Let this thing do its magic, and we will be back. All right. I believe our process is nearing completion. Yeah, okay, there we go. So if we go into the settled transactions, you can see the one at the top is the one corresponding to our bridge event. So if I click see details, this will showcase that we have moved 90 dev token from Sepolia to Arbitrum Sepolia. And if you click the success link there, we will be taken to the Arbiscan, which will show us the actual transaction that completed. So if I click that address there, this corresponds to the transactions against my Arbitrum wallet, against the dev token that was deployed. If we actually click into the contract address itself, we can see that indeed we have our dev token on the Arbitrum side fully deployed, again, automagically. And if we copy the contract address and I open up my MetaMask, we can actually import this token into our wallet. So if I click on tokens and I click on that kebab menu there on the right hand side, I can actually paste my contract address against Arbitrum Sepolia. And as you can see, it's pulling in all the data there automatically. And indeed, I have 90 dev token on Arbitrum Sepolia now, magically bridged. All right, all. That's a wrap for today's tutorial content. Just to go over what we learned today, we learned how to create a ERC20 smart contract, our dev token. We deployed that smart contract to the Ethereum Sepolia network. We learned about bridging, and in particular, we learned that the folks at Arbitrum have cooked up a snazzy bridging UI that we use to permissionlessly and without any extra code deploy our dev token to the Arbitrum Sepolia network. And just to note, all the resources that we went over in this video today will be linked in the description below, including the full repository of the dev token, as well as the steps we took to use the Arbitrum Bridge UI so you can reproduce things on your own. So be sure to hit the subscribe button and comment below on what other tutorial content you'd like to see from this platform. And with that, uh, we will catch you back here next time. All right, all. Cheers.